Hello students, I am Mudisola Kwadiola, your favorite chemistry teacher. In today's class, we are going to be looking at acid, base and salt. But to make sure that we understand very well, I will be starting with acid today. Um, our lesson focus for this session will be definition of acid and bases. We will look at classification of acids. We will look at basicity of an acid. We will look at properties of an acid. We will look at preparation of acid, and then uses of acid. So of course, when you hear the word acid, some of us think it is something that can destroy the body, and so on like that. Of course, those are part of it, but that's not it. Acids are found generally everywhere. In our laboratory, you will see a lot of reagents are made of acids, and in fact, if you want to prepare a lot of some salt and that, you will need acid. In our homes, in our food, you see acids there. In our stomach, there is a stomach acid, HCl. In our foods, we have organic acids there. So acids are everywhere, and it is important that we know and learn about them. So let's go on and take the ride. Now we will start with definition of acid. We'll start with definition of acid. Now acids are defined based on three theories. Number one, we have the Arrhenius theory. We have the Arrhenius theory. The Arrhenius theory. Now, Arrhenius defined an acid as a substance which, when dissolved in water, produces hydrozonium ion. Arrhenius defined an acid as a substance which, when dissolved in water, produces hydrozonium ion. Of course, please take note that whenever you see H plus, we usually use H plus to represent acid. So when you have H plus with water, dissolved in water, it produces H3O plus, which is our hydrozonium ion. So Arrhenius defined an acid as a substance which, when dissolved in water, produces hydrozonium ion. That's Arrhenius definition of an acid. Now another definition of an acid is by Bronsted-Lowry. Bronsted-Lowry defined an acid as a proton donor. Bronsted-Lowry defined an acid as a proton donor. Let's say for instance you have a reaction between HCl plus NH3 to give NH4Cl. Now, looking at this reaction critically, you have H plus Cl minus plus NH3. So this is donating the proton to this. So you have, that's why you're having NH4 plus Cl minus. So the acid is donating its own proton to it. So acids are defined as proton donor by Bronsted-Lowry. So Bronsted-Lowry definition of an acid is a proton donor. Okay, now let's also look at the third one, the third definition of an acid. The third definition of an acid is by Lewis. Lewis defined an acid as an electron pair acceptor. Lewis defined an acid as an electron pair acceptor. Recall during bonding, we looked at coordinate covalent bond where there is unequal sharing of electron. That means that you have A and B. A has electron, B does not have electron, okay, but they still share the electron. Okay, so this is coordinate covalent bonding. So Lewis defined an acid that, let's assume you have the HCl and then the NH3 again, or let's say you have H plus, let's use H plus to represent that, and NH3. You recall that under covalent bonding there is a lone pair of electron on nitrogen. So this lone pair of electron is used to bond with this acid here. So this acid will accept the electron pair so that it can form bond with the base. So an acid is an electron pair acceptor. This is the definition by Lewis. An acid is an electron pair acceptor. So a quick recap, definition by Arrhenius: an acid is a substance which, when dissolved in water, produces hydrozonium ion. By Bonstellori, an acid is a proton donor, while by Lewis, an acid is an electron pair acceptor. Okay, now let's look at classification of an acid. Let's look at classification of an acid. Classification of an acid. Now, acids are generally classified, number one, according to myself now, based on their nature or their occurrence. Nature or occurrence. Now, acids are classified as inorganic acid, inorganic acid, and organic acid. Inorganic acid and organic acid. Now, organic acid are acids that are gotten from food substances and food. They are gotten from nature. Examples are the citric acid in your orange, the lactic acid in milk, the palmitic acid in palm oil, and so on and so forth. You have all these acids. You have the ascorbic acid, you have the stearic acid, you have the fatty acid in fat and oil. So all those acids gotten from food substances and foods, they are organic acid. Okay. Now, inorganic acids are acids that are produced in a laboratory by chemical reaction, e.g., your H2SO4, your HCl, etc. They are produced they are manufactured in laboratory or in the industry, so by chemical reactions or chemical processes. So they are inorganic acid. Now, acids are also classified based on ionization. That means their ability to ionize in aqueous solution. Now, based on ionization, we have the strong acid and the weak acid. We have the strong acid and the weak acid. Now, the strong acid are acids that completely ionize in solution. Strong acids are acids that completely ionize in solution. An example of strong acid is H2SO4. H2SO4. If you look at the reaction very well, you have 2H plus and SO4 2 minus. 2H plus and SO4 2 minus. Another one is ACl. You have H plus and Cl minus. So these are examples of strong acid. They completely ionize in solution. Now, we also have weak acid. Weak acid are acids that do not completely ionize in solution. An example of weak acid, you have ethanoic acid, CH3COOH, where you have CH3COO minus plus H plus. Now, you observe that you still have some remainders of what's it called here? Remainders of acids here, of H here. So that means they are not completely ionized. Another one is H2CO3. It is called carbonic acid. Of course, carbonic acids are found in drinks, your soft drinks. So you have HC3CO3 minus plus H plus. HCO3 minus, that's hydrogen thiocarbonate 4 ion and H plus. So these are examples of weak acid, and because they are weak because they do not completely ionize in solution. Okay. Now, the third classification of an acid is based on amount of water. So number 3, based on amount of water present. Amount of water present. Amount of water present. Now, based on the quantity of water inside the acid, we can classify it as either a concentrated acid, or a dilute acid. A concentrated acid or a dilute acid. A concentrated acid is an acid that have little amount of water inside of it. So the acid is much than the water. It has little amount. The acid is much than the water inside of it. So that's why you hear the word CnH2SO4. And when they say CnH2SO4, that means it is concentrated. The acid is much than the water. Very little amount of water is present. That one is very corrosive. If you follow your skin, it can have a corrosive effect on that skin. Okay. Now, dilute acid are acid that have small amount of water in them. They have small amount of water in them. Small amount of water in them. So that means that the water is much than the acid. This time around, the water is much than the acid. So this is this is classification of an acid. So a quick recap. Acids are classified, one, based on nature or occurrence, and we have two types there: organic acid, which are found in nature; inorganic acid, which are made from the lab or industry. We have classification based on ionization in solution. We have the strong acid that completely ionize in solution, and then you have the weak acid that partially ionize in solution. Then, based on the amount of water present, we have dilute acid and concentrated acid. Dilute acid and concentrated acid. So let's look at the basicity of an acid. The basicity of an acid. The basicity of an acid is defined as the number of replaceable hydrogen ion in 1 mole of an acid. The number of replaceable hydrogen ion in 1 mole of an acid. Now, in a typical ionic solution or in a typical aqueous solution, how many mole of that H plus can ionize? Okay, that's basicity. The number of replaceable hydrogen ion in 1 mole of an acid. Now, based on basicity, now we now have monobasic acid, dibasic acid, and tribasic acid. For instance, if you have ACl, if ACl ionize it, it gives us H plus and Cl minus. H plus and Cl minus. You will check here that there is nothing here. It means 1. That means the number of hydrogen ion you can replace is what? 1, because this is H plus. Only 1 is there. Then that means this one is a monobasic acid. Monobasic acid is a monobasic acid. Now you can have your H2SO4. When H2SO4 ionize in solution, you have 2H plus and SO4 2 minus. 2H plus and SO4 2 minus. So the number of hydrogen ion you can replace here is what? 2. Therefore, H2SO4 is dibasic. It's a dibasic acid. Then you have H3PO4. H3PO4. You have 3H plus PO4 3 minus. Because it has 3 hydrogen ion that you can replace, you have it as tribasic acid. Tribasic acid. So under basicity of an acid, we say basicity of an acid is number of hydrogen ion that you can replace in 1 mole of an acid. So you have the one, if it is 1 like this, you have monobasic. If it is 2, you have dibasic. If it is 3, you have tribasic. That is basicity of an acid. Now let's look at properties of an acid. Properties of an acid. Properties of an acid. Now there are 3. Of course, there are physical properties and chemical properties. So under properties now, we have the physical properties of an acid. Now, number 1, an acid turns blue litmus paper red. So if you have a sample of a dilute acid in your lab, so just take a blue litmus paper and dip it inside. the blue litmus paper will turn to red, indicating the presence of an acid. Then number 2, acids usually have a sour taste. Acids usually have a sour taste. That is what is responsible for the sourness of some of our food substances like milk. When you expose milk over a long period of time, the milk gets sour. The same thing with beans. Milk has lactic acid inside of it, so when you expose it, you get a sour taste. The same thing with lemon. Lemons have tartaric acid in them. The same with beans. If you expose beans for over a long period of time or it gets spoiled, you can see the sour taste that is there. So acid usually have sour taste. And number 3, the corrosive form of acid, the concentrated form of acid, concentrated acid are highly corrosive. Concentrated acid are highly corrosive. Concentrated acid are highly corrosive. That is why if you take a sheet of paper and then you pour a conch HCl or HNO3, of course you have to do that in the presence of your teacher. If you pour a conch acid on a paper, you see the paper gets burnt. So that's what we do to your skin if you put it on your skin. So it's not advisable to put it on your skin. So they are corrosive. Okay. Now those are 3 major physical properties of acid. Now to chemical properties. To chemical properties. Now the first chemical property is reaction with metals. When acids react with metals, they displace they produce hydrogen gas. That's a major product. So when they ask you what is the byproduct of reaction of an acid with a metal, most of the time it's always a moderately reactive metal. Okay, when they react with a metal, they produce hydrogen gas as the byproduct. An example is when zinc reacts with HCl. When zinc reacts with HCl, it produces ZnCl2 aqueous plus H2 gas. ZnCl2 aqueous plus H2 gas. So now this is an example of a displacement reaction where the H is displaced by higher electropositive ion, which is zinc. Okay, so hydrogen is produced. Then when you have another reaction that they undergo is what is called neutralization. When acid reacts with a base, they form salt and water. When acid reacts with a base, they form salt and water. An example is, let me use HNO3 plus KOH, aqueous, it will give KNO3 aqueous plus H2O liquid. KNO3 plus H2O liquid. So when acid reacts with a base, they form salt and water. When acid reacts with a base, they form salt and water. So this is called neutralization. This is another reaction. Now they can also react with thiazocarbonate 4. So acids also reaction with trioxocarbonate 4. When they react with thiazocarbonate 4, CO2 is liberated. When they react with thiazocarbonate 4, CO2 is liberated. An example is when you have ACl, aqueous, reacting with Na2CO3 aqueous, it will form NaCl aqueous plus H2O plus CO2 gas. So CO2 is liberated during this reaction, when they react with thiazocarbonate 4, when they react with thiazocarbonate 4, CO2 is liberated. So these are chemical reactions of acids. These are chemical reactions of acid. These are chemical reactions of acid. Okay, there are three major ways to prepare an acid. So let's go to preparation of an acid. There are three major ways to prepare an acid. Number one is direct combination. An example is when hydrogen reacts with chlorine to form HCl. So usually this direct combination usually require a catalyst. So activated charcoal is used as catalyst for this reaction. The same thing happens to when hydrogen reacts with bromine to form HBr, hydrobromic acid. Platinum is always usually the catalyst there. Okay, then another one is action of water on acid anhydrides. Action of water on acid anhydrides. Acid anhydrides are substances that are oxide of non-metal which dissolve in water to form an acid. Acid anhydrides, or they are also called acidic oxide or acid anhydrides, are substances that they are oxides of non-metals that dissolve in water to produce an acid. So when an acid anhydride like CO2 is dissolved in water, it produces H2CO3, carbonic acid. So this is another way of producing acid. And then displacement of weak acid from a salt. Displacement of weak acid from a salt. Now this is a weak this is a what is it called? Displacement of weak acid. It can be displacement of weak acid or volatile acid. This equation here is signifying that this acid is produced. So it can be displacement of weak acid or volatile acid from a salt. In this case, a volatile acid is being displaced from a salt to produce HCl. So these are ways by which acid are produced. You also have precipitation method from sulfides and the like, but these are three major ways by which acid are produced. So finally, let's look at uses of acid. Uses of acid. Acids are used in various ways in production of fertilizers, of germicides, pesticides, etc. They are used as drying or dehydrating or oxidizing agent. They are used in battery lead acid accumulator as batteries. So they serve various functions across the line. So generally speaking, a recap of what we have done so far: we have defined an acid based on Arrhenius, Bonstellori, and Lewis. We have defined, we have classified acid based on nature, based on ionization, based on amount of water present. We have looked at basicity of an acid. Then we have looked at properties of an acid, physical and chemical properties. We have looked at how to prepare an acid, action of water on acid anhydrides. We have looked at direct combination. We have looked at displacement of weaker or volatile acid from their salt. And then we have looked at uses of acid. I've just mentioned three. There are a lot of them. They are in making dyes, making fertilizers, and in fact they are used in making salts. They are used in making salt, baking powders, etc. So a lot of uses like that. So this is acid. In the next section, we are going to look at base holistically. So in the next slide, we talk about base. See you in the next episode.